We're in Chapter 8, Hypothesis Testing. 8.1's Basics of Hypothesis. A hypothesis is a claim or statement about a property of a population. So I wrote down a claim we want to investigate. Hypothesis test, or the test of significance, is a procedure for testing a claim about the property of a population. So steps in hypothesis testing: we're going to make a statement regarding the nature of the population, collect evidence, that's our sample data, to test the statement, and then analyze the data to answer the plausibility of the statement. So two things next, give them both a star. First one is the null hypothesis. It's denoted H naught. It's a statement to be tested. It is a statement that's assumed true until evidence indicates otherwise. So this is called our default. It's our currently accepted value for the parameter. It's the one we assume true. And then we have our alternative hypothesis, which is denoted H1. Is the hypothesis that sample observations are influenced by some non-random cause. This is what we're trying to test. Sometimes they write, instead of H1, they will write HA. The next thing says, for example, suppose we want to determine whether a coin was fair and balanced. A null hypothesis might be that half the flips would result in heads and half would result in tails. The alternative hypothesis might be that the number of heads and tails are different. Symbolically, these hypotheses would be expressed as, so if you notice we write an H naught and an H1. And then the next thing that we have there is P, that's our parameter that we are using. It doesn't have to be a P, it could be mu, it could be sigma, or it could be sigma squared. So it can be for a proportion, a mean, standard deviation, or variance. Your null hypothesis always has an equal sign. Your alternative hypothesis has either less than, greater than, or not equal to. You only pick one of those symbols. And then if you notice there's a number after that, and that number depends on the problem that we're dealing with. This one's 0.5 because half tails and half heads. And those numbers should match for both the null and the alternative hypotheses. There are three ways with those symbols to set up the null and alternative hypotheses. One is that the equal hypothesis versus a not equal hypothesis. This is called a two-tailed test. So two-tailed means that we're going to have our values in both ends of our graph. Then we have two equal versus less than, or a left-tailed test. Left-tailed means just that left-tailed would be shaded. And then we also have a right-tailed test, so just the right would be shaded. If you look at your null hypotheses on all of these, they're all exactly the same. The difference is going to be your alternative hypotheses, H1. If you notice, they all start with the same parameter, and then the sum value would be the same value that you would have. But if it's a two-tailed test, we have a not equals to. If it's a left-tailed test, we have a less than symbol. If it's a right-tailed test, we have a greater than symbol. The example right below says, the null and alternative hypotheses are given. Determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed. And then what parameter is being tested. So for the first one, the parameter that we have is proportions, because that's a P in there, saying for proportions. And we do have a less than symbol in here, which is our left tail test. For B, we have sigma, and sigma stands for the standard deviation. And then we have an equal sign for our null, and that's the same for both of them. And for this one, we have a greater than symbol, which is going to be a right-tailed test. So the next thing is on page 2. It says determine the null and the alternative hypotheses. First example on here, part A, says according to the National Association of Home Builders, the mean price of an existing single-family home in 2009 was $218,600. A real estate broker believes that because of the recent credit crunch, the mean price has decreased since then. So we need to come up with our null, which is going to be H naught, and our alternative, which is H1. The parameter that we are dealing with here is mean. So we're going to go ahead and put mu for both of these. Your null always gets an equal sign. And that number that we have that we're talking about in here is 218,600. Now the word here says decreased, and that symbolizes what we're going to be putting in for our alternative hypotheses. Decreased means it's going to be less than, and that value also needs to be exactly the same as it was in the null. For part B, it says in 2010, the standard deviation SAT score on the critical reading test for all students taking the exam was 112. A teacher believes that due to changes in high school curricula, the standard deviation of critical reading test scores is different than in 2010. So it does say that we are talking about the standard deviation. And since it's a standard deviation, I'm going to go ahead and put my H naught, my H1, put your standard deviation, which is sigma. The null always gets an equal sign. The number that we have for our standard deviation is 112. And it does say that it is different. That's our key word here. And different would mean that it's not equal to 112. We don't know if it increased or decreased. We just know that it's not the same. So the next thing on here is 4 outcomes from hypothesis testing. I want you guys to look that over on your own. This stuff that's talking about a type 1 error and a type 2 error. And then it also puts this process into a court trial, which makes a lot more sense as you're reading this. And so I want you guys to kind of look through this on your own. At the bottom we have the probability of making a type 1 or type 2 error. This is alpha and beta. We are actually going to not have this on any of our tests. We are just going to, our quizzes, we will see it maybe in some homework assignments, but it will not be asked on an exam. So that means that you guys can look at these on your own to get some help, but we'll say that it's not something that's going to be required to really understand